focusing particularly on the number system. We in 6th grade talked about negative numbers, but just more frequently how to place them on the number line. We're now actually going to work with them by adding, subtracting, multiplying, and dividing. There's two main ways that we're going to add and subtract, multiply, and divide them. I'm going to show you using a number line, which is the most common way, but then also using chips, positive and negative chips. You can get the positive and negative chips online and print them off, color them, and have them in front of you to use them for manipulatives, or there's an online virtual manipulatives that I'm going to show you through. So as a refresher, this is what we would have done in 3rd grade. The temperature one December morning was 3 degrees Celsius. It rose 4 degrees by the afternoon. The temperature that evening was 4 degrees Celsius. It dropped 5 more degrees by 6 a.m. the next morning. Show the 4 temperatures using the vertical number line. We're not going to use positive negative chips because we're not actually adding or subtracting together, but one moment here. Okay, so if the temperature one morning was 3 degrees, we find that that is positive 3 on our number line. If it rose 4 degrees by the afternoon, we know that 3 plus 4 would give us 7. The temperature that evening was negative 4. So it just gives us a point, so we plot negative 4. Then it dropped 5 more degrees. So if it dropped, it's getting colder 5 more. So we'll go 1, 2, 3, 4, 5, ending up at negative 9. When you add positive and negative numbers, is your answer positive or negative? So let's review what are integers. Integers include positive and negative whole numbers as well as 0. Addition is the process of joining two groups, so an addend plus an addend equals the sum. So we know that anything to the right of 0 is positive, anything to the left of 0 is negative, and in case you didn't know, 0 is neither positive or negative in itself. But notice that anytime we move left, regardless if we're on the positive or the negative sign, we're moving in the negative direction. And anytime we move right, whether in the positive or the negative side, we're moving in a positive direction. Model the following on the number line and with positive negative chips. So let's say I have 8 plus a negative 2. So we start at 0 and we move 8 in the positive direction. Now we're going to add negative 2 to it. So we need to now go in the negative direction 2 units, giving us 6. 8 plus negative 13. So again, we'll start at 8. And this time we will add negative 13. So we need to go 13 in the negative direction. I should say 13. It was giving the answer, apparently. So we have to think about how far we would go. Well, 8 would be from 8 to 0, and then we would need to go 5 more to make our total distance 13, negative 13. So our final answer would be negative 5. Let's show this using virtual manipulatives. So the one in particular that I'm using is the one that's labeled virtual algebra tiles, base 10 blocks, and number lines. And I'm just going to click on the algebra tiles one, and I'm going to use the unit tile because I can turn them positive and negative. So I'm going to just bring out 2 of them here real quick, make one positive and one negative. We know that if we were to click these together, that a positive 1 and a negative 1 would make a group of 0. So just keep that in mind. But let's say we have 8, and we know that's positive 8. So 1, 2, 3, 4, 5, 6, 7, and 8. And now we want to add more to our group, so we're going to add 2 negatives to our group. Well, I see then that I have 2 sets of 0 that would ideally just cancel themselves out, leaving us with 1, 2, 3, 4, 5, positive 6. Okay, so let's start with these 8 again. And we need to add in 13 negatives. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and all of these are negatives. I'm just going to go click on them once to turn them negative. Okay, well, I see that I'm going to have a bunch of them pair up to be 0. Leaving me with 1, 2, 3, 4, -5 left over. I really like counters like this. This is a really great opportunity for students to get an introduction and to work with them. A number line, in my opinion, is more abstract, but it's still visual model. So I like working with both of these with my students. All right, so we had -5 above. We did both of them with positive negative chips. It says now show the following using positive and negative chips. Okay, the first one is 5 plus -2. So I'm going to start with 5 in my group. 1, 2, 3, 4, 5, and I'm going to add -2 to my group. So I see that these create a group of 0, leaving me with 3 left over. Then I have -7 plus 3. 1, 2, 3, 4, 5, 6, and 7. Oops. 1, 2, 3, 4, 5, 6, 7. And then we want to add to it 3. Here we create a group of 0, so we have -4 left over. Another good one is, let's look at -6 plus -5. So let's start off with the -6. 1, 2, 3, 4, 5, 6. And then we want to add to it -5 more. 1, 2, 3, 4, 5. So since we are negative and we're adding more negative, notice that we don't have any groups of 0. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So -11. So at this point, I think you get the idea of how to work with adding positives and negatives and what makes a group of 0. You may try the rest and the remaining on your own. Use a number line to fill in the blank. Pause the video and see if you can't make this happen, and then come back. So the first statement I have is 2 plus what gives me -8. So if I were to start at 2, if I wanted to go -8, I need to go in the opposite direction to -8. So then I went a distance of 2 plus 5, so it'd be 7, plus 3 more. So I went a distance of -10 units to the left. -6 plus 1, plus what is -1? So I start at -6. I need to turn around and come back to -1, which is a distance of 4 units. So, excuse me, 5 units. So -6 plus 5 is -1. We can find sums of integers by thinking about distance and direction on the number line. Previously, we would have items such as 2/3 plus 5/3. So we would start at 2/3 and go a distance of 5/3 more to get to 7/3. But what if we're adding 2/3 plus a -5/3? So we would start at 2/3 and now we need to go in the opposite direction, or the negative direction, 5/3 units. So to go from 2/3 to 0 is 2/3 distance, and I need to go 3/3 more, continuing that direction. In both cases, we traveled a distance of 5/3. However, in one direction we traveled positively, and in the other we traveled negatively. And once we approached 0, we had to think a little bit about how that would be affected. We can find sums of integers, still thinking of their distances, but what if our denominators are not the same? Well, we know that we need to make them the same regardless. They need to have the same unit that we're talking about. So negative 2/3 plus 3/4 is the same as negative 8/12 plus 9/12. So we'll start at negative 8/12. We need to add 9/12 more. So to get from negative 8/12 to 0, we're moving in the positive direction, 8/12 of a space, but we need to go one more 12th to get to 9/12. So our final answer is 1/12. Similarly, thinking of 5/3 plus negative 2/4, if I start at 5 and 3/10, I need to go add a distance of negative 2 and 4/10. I know that I'm not going to quite reach 0 yet because 5 is much greater than 2. So ideally this just turns into a subtraction problem to get 2 and 9/10. However, if I were to start at 2 and 4/10 and subtract and add a negative 5 and 3/10, I would first need to go a negative distance of 2 and 4/10, and I would still need to go 2 and 9/10 more to get to negative, to add up to negative 5 and 3/10. So this would be negative 2 and 9/10. Complete the following using positive and negative chips. The first one was 10 plus 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13. So you need 4 more to get to 17. 1, 2, 3, 4. Perfect. The next one was 10 minus 7. So here I have 10 and I need to subtract away 7. So 1, 2, 3, 4, 5, 6, 7. So we're left with 3. Then we had 4 plus 3. So there's 4 plus 3 more. 1, 2, 3. So a total of 7 units. And then the next one after that was 4 minus 3. So if we started with 4 and subtracted 3, 1, 2, 3, that would leave us with 1. This can also show us and help show us which direction we're going to go on if we're moving positively or negatively. So if I were to start at 10 with that first one, we ultimately moved in the positive direction because we added more positive to it, and we ended at 17. The second one, we started at 10 and we were subtracting, so we were taking away things, moving us in the negative direction. And we ended up at positive 3. The third one, we started at 4. Again, we moved in the positive direction because we were adding more to it. We weren't adding negative, we were adding positives, so we ended up at 7. And then the last one here, we started at 4. This time we added a negative 3, so we went negative distance, or subtracted, and we ended up at 1. Jack says if adding 7 and subtracting 7 go in opposite directions, then adding negative 7 and subtracting negative 7 should also go in opposite directions as well. Jill says, I don't know, Jack. That would mean if you start at 4, then add 7 or subtract negative 7, you end up at the same place. Let's create an argument that supports or disproves Jack's claim. We can think of adding and subtracting 7 as moving in opposite directions on the number line. So 4 plus 7 is equal to 4 minus a negative 7. So if we take a look at our objectives here, we see that 4 plus 7 would give us 11, but if we're adding negative 7, we would go in the opposite direction. I also know that 4 subtract 7 is in the opposite direction. Well then, therefore, these two pieces here would move in the opposite direction, just as adding and subtracting 7 moves in opposite directions. So 4 minus 7 and 4 plus a negative 7 are also equivalent. Since 4 plus 7 and 4 minus 7 move in opposite directions, and 4 minus a negative 7 and 4 plus a negative 7 moves in opposite directions. So Jack's claim is correct. Complete the table with yes or no. Pause the video and see if you can't see or identify if these claims are equivalent or not. Negative 5 plus 8 and negative 5 plus a negative 8 are not the same. Negative 5 minus 8 and negative 5 plus 8. So thinking about negative 5 minus 8, we would start at negative 5 and we would subtract 8 more, so we would be getting more negative. Whereas negative 5 plus 8 means we need to move in the positive direction, so we're going the opposites. If I have negative 5 and I add negative 8, is that the same as negative 5 minus 8? Yes, it is. And further, negative 5 minus a negative 8 means we're going to move in the opposite direction of what we think. And negative 5 plus 8 would be moving in the positive direction. So ideally, they're both moving in the positive direction. So let's verify this with positive and negative chips. Let's start with the first one. It was negative 5 plus 8. So here's negative 5. 1, 2, 3, 4, 5, and we want to add 8 to it. 1, 2, 3, 4, 5, 6, 7, 8. So I see that we have a positive 3. Is that the same as negative 5? 1, 2, 3, 4, 5. So this has to be negative, so I need to turn them to negative. And then adding 8 more negatives. So 1, 2, 3, 4, 5, 6, 7, 8. So adding 8 more negatives. 1, 2, 3, 4, 5, 6, 7, 8. So we added 8 more negatives to the 5 that we already have. So we have negative 13. So these are not the same. The next one was negative 5 minus 8. So I have negative 5, 1, 2, 3, 4, 5. I need to take away a positive 8. I don't have a positive 8 here to take away. So what we're going to do is manipulate this a little bit by adding in groups of 0, particularly 8 groups of 0, so that I can take away a positive 8. And I know that seems silly, but I don't have a positive 8 to take away. So the only thing we know how to do at this point is adding groups of 0. 1, 2, 3, 4, 5, 6, 7, 8. Because we know that adding 0 doesn't change anything. So I have 8 groups of 0 here, and I have my negative 5 that we started with. So if I have negative 5, now I can subtract 8. Subtract a positive 8. 2, 3, 4, 5, 6, 7, 8, leaving me with negative 13. However, if I have negative 5, 1, 2, 3, 4, 5, and we want to add 8, a positive 8, 1, 2, 3, 4, 5, 6, 7, 8. I see that this result is positive 3. So that's why the first two both were not equivalent. The third one down is negative 5 plus negative 8. So we have negative 5 plus negative 8. 1, 2, oops. All right, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Okay, the second one is negative 5 minus 8 more. But that's the same as the last one, so we didn't have enough, so negative 5 minus a positive 8. We don't have a positive 8 to get there, so we need to add a group of zeros. Oops, just kind of moving everything around here. Okay, so a group of zeros. So that I can take away a positive 8, leaving me with negative 13, which is what the left-hand side said. So these were equivalent before I took them away. Okay, so then if I start the very bottom row, we have negative 5. I need to take away negative 8, but I don't have negative 8 to take away. I only have 5. So I would need 3 more groups of 0 so that I have enough pieces to take away a positive 8, or take away negative 8. So here we started with negative 5. I need to take away negative 8, but I only had 5 to take away, so we needed to add 3 more so that I would have 8 to take away. So if I take away a negative 8, I see I'm left with positive 3. Is that the same as saying negative 5, 2, 3, 4, 5, adding 8, 1, 2, 3, 4, 5, 6, 7, 8. Here then I've created 5 groups of 0 which would disappear, leaving us with just 3 positives. So these are the same. I really like using the positive negative chips because it really solidifies if we should have a positive or negative answer. It's a different way to think about manipulation and visual models. Number lines are great too, but I feel like you've probably worked with the number lines, so you're super comfortable, and positive negative chips might not be so comfortable with you at this time. The additive inverse. Did you know we can turn a subtraction problem into an addition problem? So here I have a set of subtraction problems. Let's turn them into addition problems, something that we're more comfortable with perhaps. So 8 minus 3 is the same as 8 plus a negative 3, or 7 plus a negative 13, or negative 15 plus a negative 6, and negative 2 plus 9. Oh, this should be plus a negative 9. No, plus 9. Go ahead, try using positive and negative chips to verify that these statements are in fact true. So pause the video, play around with your chips a little bit to see if these are true. Subtraction gives the same result as adding the additive inverse, or opposite of a number. The inverse relationships between addition and subtraction help us to add and subtract with integers. A meteorologist recorded the temperatures for Denver, Colorado for 1 week, but forgot to use numbers. Use the written statements to determine the actual daily temperature as compared to the previous day. So on Monday it was 0. On Tuesday it was half a degree colder. So if we were at 0 and it's half a degree more cold, we would be at -1/2 a degree. On Wednesday there was no change, so it would stay at -1/2. On Thursday it was 11.5 degrees colder. So if we're already at -1/2, half would bring us to -1. If we go 11 more, here'd be 2, 4, 6, 8, 10, 11. So -12 degrees. If we're at -12 degrees and now we warm up 8 degrees, here we would have, and notice it goes by 2's, so -12 plus 8, so 1, 2, 3, 4, 5, 6, 7, 8, bringing us to -4. On Saturday, it was 7 degrees warmer. So if we're at -4 and it is 7 degrees warmer, 1, 2, 3, 4, 4, 5, 6, 7. So positive. That's why from -1 to 0, it's a whole jump. So bear with me here. All right. So -4, 1, 2, 3, 4, 5, 6, 7. So +3 degrees. Got to be careful how they've got it outlined there. And then if we're at 3 and it's 6 degrees colder, 1, 2, 3, 4, 5, 6, -3. The relationship between adding and subtracting holds for the set of rational numbers. What patterns do we see when we're adding and subtracting positive and negative numbers? Let's start with the pattern when the operation and the sign are the same. So let's use positive negative chips to show 3 plus a +2 and -5 minus a -2. Okay, so we started with 3 plus a +2. And then we have -5, take away -2. So when I take away -2, I'm left with -3. And when I have 3 add a +2, I'm left with 5. So in both instances, I see that I'm actually adding. Two like signs mean we move in the positive direction or add. Let's move on when the operations of the signs are different. -3 plus -2 and -2 plus, minus a +3. So here I have -3 and I want to add in -2, which gives me -5. So I'm actually subtracting more. And -2 plus a -3 also means that I'm subtracting more. So two unlike signs means move in the negative direction or subtract. Mr. Wages says, my balance is $0. However, the hospital says your balance is -$102.32. Determine who is right. If any mistakes were made in Mr. Wages' table, describe where they are and why they're mistakes. So if he charged to his account, that means we're going to subtract because that's what he owes, $131.06. He paid a portion of his bill, and that would make sense that it would get smaller to $86.06. That's correct. Further, if he paid $45 more to his bill, then of course he should be getting more towards 0 if he's paying off his bill. But then I look at $25.31 that he charged. Here it looks at negative 15.75 that he took negative 41 and added 25.31 instead of subtracted. So here Mr. Wages should have subtracted, not added. So his new balance, not 15.75, should be at negative 41.06, subtract 25.31. So he should be at negative $66.37. Further then, that would then affect everything from here on out. So the next step then would be to take negative $66.31, subtract, since he charged $35.75. So now he owes $102.12. Again, he charged some more, so we need to keep subtracting, keep getting more negative for a new balance of negative 127.97. He also charged another time 176.09, which now he is in the hole negative $304.06, but he did pay $201.74, so we get to add that. So his balance, sure enough, is really negative $102.32. Show 2 times 3 on a number line. How would you draw the opposite of 2 times 3 on a number line? So 2 times 3 is 2 copies of 3. And then the opposite would be subtracting 2 copies of 3. So let's use a number line to show 2 times 8 and 2 times negative 8. So we want 2 times the length of 8 in the positive direction. So we start at 0, there's 8, and we go twice to get to 16. Here we want 2 times the length of 8 in the negative direction. So we go 2 copies of 8 in the negative direction for negative 16. Negative 2 times 8, the opposite of 2 times the length of 8 in the positive direction. So we originally would think that this would be 2 copies of 8 in the positive direction, but then that negative part comes, and that means we have to swing it to the opposite direction. So negative 16. Further, negative 2 times negative 8, the opposite of 2 times the length of 8 in the negative direction. So we originally think that it is 2 times the length of 8, but we want it in the opposite of the negative direction, giving us positive 16. So let's follow up with chips. All right, so 2 times 8 means that I want to add in two copies of 8. 1, 2, 3, 4, 5, 6, 7, 8. So I want to add in 2 of these. Perfect for positive 16. That one's not the issue. All right, so then I want to add in 2 copies of negative 8. Well, here's 1, 2, 3, 4, 5, 6, 7, 8. There's 1 copy. So we added in to our circle here 2 copies of negative 8, which would be negative 16. The next one, negative 2 times 8. So I want to remove twice. I want to remove twice. Think about this. Remove twice, or remove 2 times 8 copies, positive 8. So remove twice a copy of 8, copies of 8. Well, if I start with nothing here, there's nothing I can remove. So what I need to do is add in some zeros. So here is so that I can remove 2 copies of 8. So there's 1 copy of 8. I know it feels like we're probably adding in way more than we need to, but we're truly not. So we need to add in some zeros. Okay, a couple more. All right, so we need to remove 2 copies of 8. So, and they're positive 8. So if I remove 1, 2, 3, 4, 5, 6, 7, 8. There's 1 copy. Here's 1, 2, 3, 4, 5, 6, 7, 8. There's 2 copies. I am then left with negative 16. Remove twice or remove 2 copies of negative 8. So we don't, if we started with nothing in our pieces, in our whole here, what we need to do is add in the zeros again, enough so that we can remove twice or remove 2 copies of negative 8. So we're going to actually remove the opposite of what we did on the previous set. So remove 2 copies of negative 8. 1, 2, 3, 4, 5, 6, 7, 8. There's 1 copy. 1, 2, 3, 4, 5, 6, 7, 8. So we're left with positive 16. We have discovered these patterns when multiplying with negative numbers. A negative times a negative gives us a positive result. A negative times a positive or a positive times a negative give a negative result. Each number line shows the final representation of a multiplication equation. Write 2 possible multiplication equations that are represented by each number line. Pause the video and see if you can't come up with a couple. The first one here, I see I have 4 copies of 2. And then we also could do, since we know a negative times a negative is a positive, we could remove 4 groups of negative 2. And we know that that would bring us to a positive. The second line here, we have 2 groups of negative 5, or remove 2 groups of positive 5, which would give us also negative 10. Use a number line to show the following division problems. We already know how to represent multiplication with negative numbers on the number line. So let's use our inverse properties to rewrite each division as a multiplication. So 8 divided by 4 is the same as asking 8 equals what times 4? So how many times a length of 4 in the positive direction to get to 8? Well, that would be 2 of them, positive 2. Negative 8 divided by negative 4 is the same as negative 8 equals how many times a length of 4 in the negative direction to get negative 8. So we need to go in the negative direction 2 times so that we get negative 8. Negative 8 divided by 4. Negative 8 equals what? How many times a length of 4 in the positive direction to get negative 8? Again, we have to think, well, we would go in the positive direction this way. However, we need to get to negative 8, so we have to think the inverse or the reverse of that, so negative 2. And negative 8 equals how many times a length of 4 in the negative direction to get positive or to get to 8. This should be this way. So we would originally think that if we were going 4 in the negative direction to get to 8, but we need to be in the positive for a final answer of positive 8, so we would be positive 2. Show using positive and negative chips. All right, we're starting with 8 divided by 4. So we want to know how many groups of 4 that we can make. So how many groups of positive 4 can we make? Well, we can make 2 groups. Let's do then, the same is true if we have negative 8 divided by negative 4. How many groups can we make of negative 4? Well, we can make 1, we can make 2 groups. Let's start then with negative 8 divided by positive 4. Negative 8 divided. Okay, so we're at negative 8 divided by positive 4. So if I were to split this into 4 groups, each group would have negative 2. Our problem comes in when we have 8 divided by negative 4. I can't take a positive 8 and then divide it into 1, 2, 3, 4, 5, 6, 7, 8. I can't take a positive 8 and divide it into a negative 4 groups. That doesn't make sense. So we have to rely on the multiplication aspect of this same problem, because that's this is the only part where this model almost falls apart. So what times negative 4 gives me positive 8? So what we need to do is put in here some items so that we can remove groups of negative 4. So how many groups of negative 4 do we have to remove so that we end up with 8? So I just simply added in a bunch of different groups here of negative, of 0. So now I can remove one group of negative 4, and I can remove a second group of negative 4. So I removed 2 groups, so negative 2 times negative 4 leaves me with positive 8. So turning it into a multiplication problem helps us simplify this particular problem. All in all, we have discovered these patterns when dividing with negative numbers, that a negative divided by a negative is a positive divided by a positive is a negative, and a positive divided by a negative is a negative. Show 10 divided by negative 2 on a number line. We turn it into multiplication. So 10 is how many times a length of 2 in the negative direction to get positive 10? Well, we know that if we go negative 5 lengths of 2, we would get to negative 10. However, we need to think of that as the opposite. So going the opposite would bring us to a positive 10, and we would need then 5 groups of 2 to get to a positive 10. So that would be negative 5 helped us do the opposite of what we were thinking. For each observation, calculate the rate at which temperature changes as altitude changes in degrees Celsius per kilometer. Predict what the temperature would be if the scientist went from his lab to an altitude of 4.4 kilometers, and explain. So some of the chart is already filled out for us. So if we look at the start and the end altitude and then its change, we can fill in the table by counting. So it's a positive 4/10 of a change, positive 1 and 71/100 of a change. Here we went -2/10 because if we start at 1/10 and we go to -1/10 on the number line, we've gone a distance of -2/10. Similarly, -4/10 and then the last one a +2 4/10. We can find the change in temperature by following the same idea. So we fell 2.5 degrees, we fell 10.1 degrees, we gained 1 2/10 degrees, we gained 2 7/10 of a degree, and then we fell 14 9/10 of a degree. We then can identify the rate of change per kilometer with division. So the change of temperature divided by the change in altitude, which gives us these changes. So -6 and 25 hundredths, -6 and 4/10, -6, -6 and 75 hundredths, and -6 and 2/10. So although the changes seemed kind of drastic and all around, our rate of change is very similar. Our prediction, if an altitude of 4.4 kilometers and explain. So our starting altitude has been the same and our altitude of 4 4/10 is listed. So its change would be to add 4 3/10 of a change. So now we can identify what the average rate of change is for the temperature. So we can add them all up and divide by 5 because that's how many there are. So the rate of change per kilometer average is -6 32 hundredths. We could figure out the temperature change by taking -6 32 hundredths, multiplying it by 4 3/10, so going the opposite of how we found them, so reversing the rules. So for an end change of -27 2/10. So then we can find the starting temperature or the ending temperature by taking -27 2/10 and adding 20 to get an ending temperature of -7 2/10. The same pattern exists when we use multiplication and division with negative numbers.